Good morning, everyone. Welcome to Computer Lab Space. Don't forget to check my previous videos. I have covered or I have explained basic structure of C program, types of files in C, how to compile and execute C program, then C character set, C tokens. In that I have explained keywords, identifiers, and today we will learn constants. Okay? So I will just run through the slides. Yes. Constants. So what is constant? The data value which cannot be changed, right? So when? During the execution of a program. So we have a fixed value assigned to an identifier. I already explained what is an identifier. Check my previous video about identifiers. So identifiers are the names given to the variable name, then array name, function name, okay, to identify. So that is what an identifier, and fixed value assigned to an identifier, and that value cannot be changed during the execution of a program. We call it as constant. We call it as constant. Then we have integer constant, floating point or real constant, character constant, then string constants. In the integer constant, we have decimal, octal, hexadecimal, integer constant. We'll start with the integer constant. In the integer constant, integer means what? A whole number. So an integer constant should have a whole number. Whole number, it is nothing but does not have a decimal point. Does not have a decimal point. For example, 555. Yes, no decimal point is there. For example, if I write 5.5, yes, it will become a floating or real constant. So not this one. Without having a decimal point, we consider whole numbers as the integer constants. And in that we have decimal. Decimal, it is nothing but 10. The combination of 10 digits. So the constants having a digit combination which ranges from 0 to 9, 0 to 9. So total in turn we have 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many are there here? 10. We have 10, right? So the combination of this 0 to 9, we call it as a decimal integer constant. Decimal integer constant. And this number or digit can be a positive or negative. For example, if I write plus 58, yes, it is a positive number. Minus 58, it can also be a decimal integer constant. But keep in mind, if I didn't specify any symbol, by default it will be considered as a positive number only. By default it will be considered as a positive number only. And there should be no commas or blanks should be there between a digit. For example, if I write 5, then one space, a single space, then 8, it cannot be a valid decimal integer constant. Is it clear? It can be considered as a two different number which can two different number, but it cannot be considered as a 58 as a digit. Okay. So no commas or blanks can be allowed as a integer constant. It is like just decimal, whether it is a decimal or octal or hexadecimal, but it cannot be considered as a integer constant. Is it clear? And in this, I have just given few valid examples, invalid example. So minus 58, yes, it is a negative digit, fine, it can be. Then 756, yes. Then 4321, yes. Then 23456, here one space is there, so it cannot be. It is an invalid example. And here a decimal point has been included, so it cannot be. Then minus plus 69, whether a number can be a positive one and it can also become a negative number, but together I cannot combine together and give a signs like this. Okay, so it is invalid. Next we will go for the octal. Octal means what? 8, a combination of 8, so which ranges from 0 to 7. So in turn it contains 8 digits, right? And again the same things we need to follow. A number can be a positive number or a negative number, but together we cannot be included. Plus minus like 5 7, it cannot be included. And we will identify the octal integer constant by prefixing 0. So, if we look at these examples, 077, yes, 77, it is in the range of this octal, that is 0 to 7, so it is a valid. And here also 7, yes, it is a combination between 0 to 7, and 5, yes, again, 6 again, and it is prefixed with 0 and sign, yes, it is a valid. Here also it is valid. Now come to invalid examples. Here a blank space has been included, so no commas, no blank spaces can be included in the integer constant, so it is invalid. Then here minus 017.7, yes, again it is a decimal point, it cannot be. And again 8 does not comes under the octal combination, so that's why it is invalid. I hope it is clear. Next, hexadecimal. Hexadecimal, that means total 16 combinations. 0 to 9, it is 10. Then A to F. A to F. A to F. Again, it is 6. So, overall, the 16 combinations, we are going to call that as hexadecimal. And here A to F, A value is 10. A value it is 10. Then B value it is 11. Then C value 12. And D value it is 13. And E value it is 14. F value it is 15. So how many are there here? 6. So 10 plus 6, 16. So that's why we call it as hexadecimal. Okay. Then the number again can be positive or negative, and we will identify hexadecimal integer constant by prefixing 0 capital X or 0 small letter x. It is 0. Okay. So here if you look at the examples, valid example 0 capital X, yes, 917. Yes, obviously it is correct. Then minus 0x1AF. AF, it is a part of our hexadecimals, so we can include. And similarly here small letter a, it is also a valid, so that's why these are the valid examples. Now come to the invalid examples. Here 18C, it is not prefixed with the 0x, so that's why we have considered this as an invalid example. Then 0x, yes, it is prefixed, but still it is invalid because it contains G, and where G is not a part of hexadecimal, right? So that is invalid. Then 0x 4.6, yes, here it is a decimal point, so that's why here it is invalid. Okay. I hope it is clear. So, in the integer constant, we have studied decimal integer constant, octal integer constant, and hexadecimal integer constant. Next, we will go with the floating point constant, or we can also call it as a real constant. And real constant or floating point constant can be written in two different forms. One is fractional form and the another one is exponential form. So whatever the constants you take, it should have at least one digit, and the difference between the integer constant and the floating point constant, it should have decimal point. Okay, decimal point. For example, if I write 2.5, yes, this is valid. If I write 25, it will become an integer constant. This cannot be a floating point constant. Just it should include a decimal point. Okay, 25.23, whatever it is. Okay, it should have a decimal point. And same thing, it can be either positive or negative, but the default sign is always positive. And similar way, no commas or blanks are allowed within the real constant. Okay. Now come to this fractional form and the exponential form. So in the fractional form, see, normal, the floating point numbers, however we will write, so the same thing we will be included as a fractional part, where integer part is going to be followed by a dot, then we are going to include the fractional part. So this is what a fractional form we will say. And comes to the exponential form. In the exponential form, we can divide this into three parts. One is mantissa, then it is the exponent, that is a symbol, small letter e or capital letter E, then exponent. What is the exponent? Okay. So for example, in this 9.86, 9.86, it is a mantissa, then capital letter E or small letter e can be included as exponent, then the exponent is 3. So we will together write it as 8.6, 9.86, sorry, into 10 power 3. So here exponent is 3, then exponent we have written, no, 10 power, to that this we are going to call it as exponent, and this is a mantissa part. Is it clear? Is it clear? I hope it is clear. This is floating point constant, and in the next video I will do character constant and string constants. I hope it is clear. If you like my teaching, subscribe to Computer Lab Space, click on the bell icon as well as thumbs up. Thank you. Have a good day.